For 13.1 and 13.2, we're talking about measures of central tendency and measures of dispersion. And all of this has to do with the collection of data and then analyzing that data. So when we're talking about measures of central tendency, we're talking about trying to find, they call it central because we're trying to find the center of the data that gives us an idea of where it typically falls. So this will be like your average, which we call mean, median, and mode. When we talk about dispersion, the measures of dispersion, we're trying to look at the broad picture of the data and look at how spread it is. So what are like those outliers, those extremes on either end? That's kind of what we're looking at there. And that is range and standard deviation. So for our definitions, statistics, the collection, organization, summarization, presentation, interpretation of data. And just so you know, if statistics does end up being something that interests you, there are a lot of jobs out there that are like analysis of data, whether that be, you know, a job before teaching or if you get a summer job or something like that. There are a lot of jobs that, and they pay pretty well, that require you to collect and analyze data. One of my coworkers' husband works for Blue Cross Blue Shield, and he's pretty high up in, I forget what his title is, but what he does is he collects data and analyzes it and makes suggestions. Measures of central tendency, they're values that locate the center of the data, mean, median, and mode. Mean is our average. It's the sum of all of the numbers divided by the number of numbers. The median is the number that falls right in the middle, and then the mode is the number or numbers that shows up most often, so it has the highest frequency. Summation notation, so you will see this Greek letter often. It's sigma. It always means sum in math. If you did any sort of like pre-calc in high school, you would have seen that quite a bit, especially when you start talking about limits and all of that. And then when we're talking about data, we have two different groups. We have a population. When we refer to the population, it's the entire group that's being considered. And when we talk about a sample, it's a small subset of that group. Okay, so we're going to start by talking through our measures of central tendency and how to find mean, median, and mode. So when we're given a set of data, the first thing we need to do is put it in order from least to greatest. I always make sure I'm crossing them out as I use them because otherwise I miss some of them. So there's 2 5s, there's a 6, a 7, an 8, a 12. So first step, get it into order from smallest to largest. Second step, we need to figure out how many numbers we have. So we're just going to count them. So this should be 8. Did I count correctly? Okay, good. So that's our n. That's our number of numbers. When we calculate the mean, what we're going to do is take all of our numbers and add them up. And then we're going to divide that by the number of numbers, which is 8. So when we add all of that up, we end up with, I'm getting 50, but can you check my math on that? Because you know how things go. Okay, 50 divided by 8, and we would end up with 6.25. So the average of all of these numbers is 6.25. The median is the number that's directly in the middle. Now, if it's an odd number of numbers, so if n was 9 or if n was 7, there is a single number in the middle. If n is even, we're going to find the two center numbers and take the average of those numbers. Really, we're just going halfway between. But 11 divided by 2 would be 5.5. That would be our median. And then our mode is any number that has the greatest frequency, so shows up the most. In this case, 5 shows up the most. So these are our three measures of central tendency. These are the ones that I would expect you to teach if you started teaching upper L. Mean, median, and mode. Let's look at example 2. So first thing we're going to do is put them in order from least to greatest. And then we're going to count the number of numbers, so our n is 5. For our mean, we're going to add all of those up. And we're going to divide that by the number of numbers, which is 5. So when we add all of that together, we get 286 divided by 5. So our mean would be 57.2. Our median, because we have an odd number, it's going to be that number that's directly in the middle, so 56. And our mode is any number that has the greatest frequency. In this case, there are no numbers repeated, so we just say no mode. All right, now let's go ahead and look then at example 3. You will notice that example 3 has a very clear outlier. So when we put these in order from least to greatest, we have 2 2s, we have 2 4s, we have a 5, a 6, a 7, and then a 38. When we count the number of numbers, our n is 8. Okay, so for the mean, we're going to go ahead and add all of these together. And we're going to divide by 8. When we add all these up, we get 68 divided by 8 for a mean of 8.5. Our median, because we have an even number of numbers, we're going to find the 2 right in the middle, which is 4 and 5, and we're going to average those together. So we end up with 4.5 for our median. And in this case, we have 2 modes. The number 2 and 4 both show up twice. So those would be the modes. Okay, so here's my question. We have a very clear outlier in this data, a number that's much larger than all the rest. How does that 38 impact the measures of central tendency? Kiana. Good. It pulls the average a lot further toward that outlier. Does it have much of an impact on the median and mode? No. Okay, so we just want to make note that it has a significant impact on the mean pulling it toward the outlier or extreme. because in this case, our mean is actually bigger than every other number except 38. Any questions on this? Okay, so then often when we get, especially into grading, we have what's called a weighted mean. So typically we would see this in calculations of GPA, which we're going to do some examples of. But also you will see it a ton in your college courses. You know, everything is weighted by category. Even in this class, we have homework is a certain percentage of your grade. Tests are a certain percentage of your grade. And what it allows you to do as a teacher is it allows you to give more value or importance to certain aspects. Now, typically when you're teaching like elementary, high school, a lot of those grades are point-based, meaning it's just a total number of points averaged out for a grade. Everything is weighted the same. Well, let me say that differently. Everything is weighted according to its point value. So if I want to weight a test more than homework, I make it more points. I think we have 1 or 2 teachers across the street that do weighting, and everyone else is point-based. So in elementary, middle school, you won't see it. High school, you won't see it as much, but college, you definitely will. When we do a weighted mean, basically what we have to do is we have to take each number, whether that be the grade, the score, whatever, we take each number and multiply it by its weight, and we add all of those up. So instead of adding just all the scores up or just all the numbers up, we multiply them by their weight first, then add them all up. Then what we do is we divide by the sum of the weights. So for most professors who weight their courses, like if you look at our syllabus and look at our weighting, it all weights, it adds up to 100 because it's 100%. But there are times, especially when we do like GPA stuff, where the sum of the weights will not be 100, it'll be something else. So we're dividing by the sum of all of the weights. So let's look at an example. So this would be calculating GPA. Most colleges, many colleges, really we could say high schools too, use the 4-point grading scale. So an A is given 4 points, a B is given 3 points, a C is given 2 points, a D is given 1 point, F is given 0. A student's GPA is then calculated as a weighted mean, where the student's grade in each course, or their point value, is given a weight equal to the number of credits. So the credits here are our weight. We need to calculate the earned GPA. So let's look at the point values. So a B we said was 3. So essentially this, in English, they got a grade of 3. In history, a grade of 4. In chemistry, a grade of 1. And in algebra, a grade of 2. Then we have all the weights, and that's what we need to add up for our sum of the weights. So when we do 4, 3, 3, 4, we get 14. All right, so our formula for weighted means says I'm going to take my point value, so my first one is 3, and I'm going to multiply it by its weight, which is 4. I'm going to add that to the next point value, which is 4, multiplied by its weight, which is 3. Add that to my next point value of 1, and multiply it by its weight of 3. Add that to my last point value of 2, and multiply that by its weight of 4. This will then be divided by the sum of the weights, which is 14. So we have 12 plus 12 plus 3 plus 8. That gives us a total of 35 divided by 14. So this student's GPA would be 2.5. Now you can go calculate your GPAs. Isn't that exciting? Okay. So the other example or situation that we use this same kind of mindset of weighted means is with frequency tables. So when you create a frequency table, basically what you do is you have your event. In this case, it's the number of bedrooms in a house. 2 bedrooms, 3 bedrooms, 4 bedrooms, 5 bedrooms. This event can be anything, but you have all of your events listed, and then you have how many times that event occurs. So this would imply that in the subdivision, 5 houses have 2 bedrooms, 25 houses have 3 bedrooms, 10 houses have 4 bedrooms, 5 houses have 5 bedrooms. So this frequency is what we're adding up to get our total, which we know should be 45 based on our instructions. So what we're going to do is find the mean number of bedrooms. So we are going to use our weighted mean process for this. Because the houses with 2 bedrooms, there are 5 of them. So we're going to do 2 times 5. And we're going to add that to 3 times the number of houses with 3 bedrooms, which is 25. We're adding that to 4 times 10 and adding that to 5 times 5. And then we will divide all of that by the total number of houses, which is 45. So we have 10 plus 75 plus 40 plus 25. That gives us a total of 150. Essentially what we're doing is we're counting the number of bedrooms in the entire subdivision, okay? So 2 houses with 5 houses with 2 bedrooms each, there's 10 bedrooms there. We're adding up all the bedrooms. Now we're going to divide that by 45 to find that there's an average or a mean of 3.3 bedrooms in the subdivision. Any questions on frequency distribution? Creating a frequency table using it. What would be our mode? Three bedrooms, right? Remember, mode is which one has the greatest frequency, which one shows up the most, okay? All right. Now let's talk measures of dispersion. So the first 3, remember, the focus is to get to the center of the data. Now we want to look at like the spread of the data. So there are 2 that we're going to look at, range and standard deviation. Range is pretty easy to calculate. It is the difference between your 2 extremes. So the largest minus the smallest. So when we calculate the range, we again are going to start by putting in order from smallest to largest. And we could easily go ahead and calculate the mean and the median and the mode if we wanted to. But for our range, we're going to take that largest value and subtract the smallest. So our range is 41. Essentially what that means is whatever this unit is, the spread of data covers 41 units, 41 numbers. Let's look at example 2. So putting these in order from least to greatest, 4, 7, 9, 12, 12, 17, 18, 24. For our range, we're going to take that 24 and subtract 4 from it to get a range of 20.
Did you mean to skip this one?
Nope, sure didn't. Oh yeah, I did number 3. That's unfortunate. We're going to go back now to number 2. Did you all write it on the right spot? You're so good. Okay, moving backwards. Which number would I list first as the smallest? So smart. -8, -4, 1, 3, -8, -4, 1, 3, 5, 10. Okay, so for our range, don't be fooled. 10 minus -8. What happens? You add them, 10 plus 8. So the range of values that's covered is 18. Does that make sense? Okay. Now we get to the challenge of today. Calculating standard deviation. Now, there is a reason that most people rely on programs or calculators to calculate standard deviation. It's because no one really wants to do all of this work. But we are going to do it without using a program you can use a calculator to do your multiplication addition, but you're going to do all the work. Just for the experience of it. Okay, so let's talk first about what it is. So standard deviation is how far off each number is from the mean. Now, here's where you will come across standard deviation in your education career. Standard deviation of a set of data is used to determine in education how much intervention or differentiation is needed for your class. So, for instance, most of the schools in the nation do a MAP test. Did you take MAP tests when you were in elementary, middle school? Okay, so NWEA MAP test. It's in different subjects: math, science, language, reading. What you then get is you get a student score that's based on the normed data. So every, I don't know how many years, 5, 6 years, they take all this data from the nation and they kind of come up with normed data like where should a second grader fall, a typical second grader fall in this subject area? Where should a typical fourth grader fall? And they all have a score, right? So each student's score is then compared to the normed data. What happens then is you can take your students' scores. So for me, it's math, right? So I can take my middle schoolers' scores and calculate the average, the mean. And then I can look at how many students are really far from that mean. That could be really high, like far positively away, or really low from that mean. And what that tells me is the more students that I have that are far from the mean, the more outliers I have. So the more I need to differentiate my instruction or provide supports or advanced options for my students. Now, when you use your MAP data, it just gives you the standard deviation. It just tells you what it is, which is really nice. But we're going to learn how it tells us that. Isn't it so exciting? I know. Okay, so variance, just so you know, it's the name of the squared standard deviation. Here's why. Do I want to say this now? No, I'll say it in a minute. Variance, the square of the standard deviation. Okay, here are all the symbols you need to know. Sigma, another Greek symbol, is used to refer to the standard deviation of an entire population. Sigma squared is the variance of an entire population. And then that other letter there is mu. Mu we use mu to refer to the mean of the entire population. Then we have S, that's the standard deviation of a sample. S squared, the variance of a sample. And then X with the bar over it is the mean of a sample. Okay, now let's talk about our formulas and our steps. Standard deviation, and I'm going to focus here on sample. I'll still reference how population's different, but I'm going to focus on sample because that's typically what we're working with. So you'll see we're taking the square root at the very end. Inside that square root bar, we have x minus that x over bar. In other words, we're taking the data, so an individual score, we're subtracting the mean to figure out how far away from that mean we are. Then we're squaring it, and we're adding all of that up. Then we divide by n minus 1, the number of numbers minus 1, and then take the square root. Okay, so just a couple things to note. The reason that we square it is because if we add up just all the standard deviations, so standard deviation, remember, we take each number, we subtract the mean. If we add up just the standard deviations, you will always end up with 0. That's just how the mathematical process of it all works out. So in order to actually calculate something, we end up squaring each of our standard deviations and adding those up. The reason we do n minus 1, there's not like a really great reason. The reason we do n minus 1 instead of n is because statisticians have found over time that when you're calculating for a small sample, doing n minus 1 gives you a more accurate answer. You'll notice that the difference if you're doing a population or a sample is that instead of subtracting the mean of the sample, you subtract the mean of the entire population. And instead of dividing by n minus 1, you just divide by n. Those are the two differences. But you will most often be using the sample. So our steps to follow. Determine the mean. For each number, calculate the deviation between the number and the mean. Square each of those deviations and find the sum of them. If your data is a population, divide by n. If it's a sample, divide by n minus 1, and then find the square root. Are you ready? Here we go. At least there's a smaller number of numbers, right? Okay. We need to find the range, the standard deviation, and the variance of the given sample. Sample is important because it tells us what symbols and equations to use. That's a typo. Round that should just say integer, not integer. Take out that n. I'm going to have to make a new key again. I have so much work to do. Okay, round non-integer results to the nearest tenth. Now, here's the deal on this. The less you round, the better. Same as what we said before. Like the more numbers you can use before you get to your end and officially round, the closer your answer is going to be. But it makes it a lot harder to work with the numbers. So I'm fine if you just round to the 10th every time. And this is why most people use calculators or programs, because then they don't have to round every time. Okay, so here we go. We're going to start by putting the numbers in order from least to greatest. So we have 48, 59, 68, 81, 87, 91, 92, 93, and 100. All right. We need to find three things. We need to find the range. We need to find the standard deviation of the sample, which we use S for that. And we need to find the variance of the sample. We use S squared for that. So this is like our answer key over here. This is what we need to calculate. The range is our easiest one. We take the largest number, subtract the smallest number. So 100 minus 48 is 52. That's our range. Now we're going to start our standard deviation process, and we're going to start that by creating a chart. The first column is going to be X. It's the number, the actual data, the actual number. Then we're going to do X minus X over bar X. I don't know how most people say that, but X minus the mean. And then we're going to do X minus the mean squared. So the deviation and then the deviation squared. In this table, we're going to list every one of our data points. 48, 59, 68, 81, 87, 91, 92, 93, and 100. Okay. Now, in order to actually fill out the second and third column, we need the mean. So now we need to find the mean of our numbers. Remember, that means we're going to do the sum divided by the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is 9. So the sum divided by 9. When we add all of those numbers up, we end up with 719. We're going to divide that by 9 for a mean, rounded to the 10th place, of 79.9. Okay, so now in our second column, we are subtracting. So we are doing 48 minus 79.9. So important to note, we are not doing like biggest number minus smallest, because we have to get negatives if the number is below the mean and positives if the number is above. So 48 minus 79.9 gives us negative 31.9. 59 minus 79.9 gives us negative 20.9. 68 minus the mean is negative 11.9. 81 minus the mean is 1.1. 87 minus the mean is 7.1. 91 minus the mean is 11.1. 92 minus the mean is 12.1. 93 minus the mean is 13.1. And 100 minus the mean is 20.1. After we do that, we are going to take those numbers we just found and we're going to square each of them, meaning multiply them by themselves. So when we square negative 31.9, we get 1,017.6. The next one is 436.8. Then 141.6. Then 1.2. Then 50.4. Then 146.4. think I missed a number. This is not good. Okay, 68, 141, 81.
Would that be the 12?
Okay, hold on. Where's my... So, all that should be fine. 7.1 times 7.1 should be fine. 50.4. 11.1 times 11.1. That's the one I missed. Okay. So that, so the 146.4 needs to be moved down one. So after 50.4, we have 123.2, then 146.4, then 171.6, and then 404.0. Okay. So now that we have this, we are going to take all of these squared deviations and we are going to add them up. And I have to add in that number that I missed. So 236, no. Okay, one of you also add all these up so you can check my math. Plus 123.2. Okay, I am getting 2,492.8. Yeah? Okay. Annika gives me a thumbs up. Okay. We are then dividing this by n minus 1. So 9 minus 1. So this is like a separate box from that. So we're going to take that and divide by 8. And we get 311.6. Okay. Now we're going to take that number, we're going to square root it. So coming back to my answer key over here, right? This is what I'm looking for. This box of answers here is my goal. The standard deviation is going to be the square root of 311.6. Which is 17.7. Question for you. If I take the square root of 311.6 and I square that square root, what happens? They cancel each other out. So our variance is just that sum of the squared deviations. Now, 17.7, like if this was my classroom and I got a standard deviation of 17.7, that would be concerning to me. Not necessarily concerning because some might be high as opposed to low, but what it tells me is I have a class that has a large spread of ability or score. So I'm going to need to account for that, whether that be intervention or advancement. I'm going to need to differentiate enough to cover that spread. Questions? Yes.
So, like, can we use, like, our calculator, like, in our stat plot, and then plug this into, like, our X, Y?
Do you mean to check your work?
Like, yeah. Well, like, could I just, yeah. Like, do you want me just to like write out the chart, I guess, in my homework? Like,
Yes,
I can't just
yeah, I do. Yeah. So for your homework and your test coming up, I want you to do it by hand and show me all your work. Now, if you have one of the giant calculators, who has one of those ones? Jade, you do. Okay. If you wanted to check your work, you can on one of these large calculators. There's a button called Stat. And then when you hit Stat, you have 3 tabs at the top. You have Edit, Calc, and Tests. When you select on Edit, what it takes you to is a list, a whole bunch of lists. You would enter all of your numbers into one of your lists. Then you would hit Stat again, and you would slide over to Calc and hit Enter on the 1 var stats, meaning one variable statistic, because you only have one list of numbers. And when you do that, it'll say, like, what list do you want? You don't have to fill in the frequency of the list. You can just hit Enter on Calculate, and it will give you your mean, your sum of the numbers. It will give you the sum squared, the standard deviation of the sample and the population. It will give you your number of numbers, your min, your quartile 1, median, quartile 3, and maximum. So you're welcome to check your work on that, and in life, you would almost always use this. But in math class, you won't. Thank you so much for that. Okay, so let's do example 2. Okay, so first thing we do is put the numbers in order from least to greatest. 3.7, 5.2, 8.2, 11.7, 16.3, and 19.1. 1, 2, 3, 4, 5, 6. So n is 6. There's 6 numbers there. What I'm looking for is range, standard deviation, and variance, which is s squared. My range, again, is my easy one. I would do 19.1 minus 3.7, and I'd end up with 15.4. This is my answer key right here. Okay. So now I'm going to create my table. So I have my x, my deviation, which is x minus the mean, and then my deviation squared, which is where I get my variance. And I'm going to list all of my data points. So 3.7, 5.2, 8.2, 11.7, 16.3, and 19.1. Now, in order to calculate my second column, I'm going to have to do my data minus my mean, which means I have to know my mean. So I'm going to take the sum and divide by 6. My sum is 64.2. When I divide that by 6, I get a mean of 10.7. So now I'm going to take each value and subtract that mean. So I would end up with negative 7, negative 5.5, negative 2.5, 1, 5.6, and 8.4. And then I'm going to square each of those. So that would give me 49, 30.3, 6.3, 1, 31.4, and 70.6. Do I need to pause for a minute? Okay. So once we get all of those, we're going to total up the variances there. So we're going to take those squared deviations and add them up, and that will give us 188.6. And then remember, we divide that 188.6 by the n minus 1. So that would be 6 minus 1, which is 5. When we divide that by 5, we get 37.7. This, remember, is our variance. And our standard deviation is going to be the square root of this, which would be 6.1. I would be a lot more comfortable with a standard deviation of 6.1 in my classroom than with a standard deviation of 17. Questions? Okay, your homework is 12 problems. 13.1 is focused on mean, median, mode, frequency tables, and then that weighted mean is in there as well. When you get to 13.2, that's where you're finding standard deviation. One of the questions is more just like a theory question, like it's asking your opinion on, it's testing your knowledge of what standard deviation is. We will go over that on Tuesday when we meet, and you are good to go.